So today we're going to be talking about balancing chemical reactions. So when we're balancing chemical reactions, what we're doing is making sure that for each atom in our compound, we have the same number of that element in the reactants, what we start out with, and in the products, what we end up with. And so the reason why we have to balance chemical reactions is because of the law of conservation of mass. So have you guys heard of the law of conservation of mass in previous science classes? Yes. What does it say? Exactly. Matter cannot be created or destroyed. And you may hear it referred to as law of conservation of matter. They're the same thing. So in chemical processes, we aren't making new atoms or destroying old atoms. All we're doing is rearranging who atoms are bonded to. So chemical reactions involve changing of bonds, right? To form new, chemically different substances. And so one way that we show a chemical reaction is balanced is by saying, okay, if we're just rearranging atoms, then the mass of our reactants, the mass of what we start out with, has to be equal to the mass of our product, or the mass of what we end up with. Does that make sense? So the way that we show that is by making sure that they're the same number of each atom in the reactants and products. So if we look at this reaction, how many carbon atoms do I have in the reactants? 2. And how many carbon atoms in the products? 2. So carbons are balanced, do we agree? How many oxygens in the reactants? 2. 1, 2. And how many oxygens in the products? 2. So are the oxygens balanced? Yes. Does this represent a chemical reaction? Yes, right? I started out with 2 separate carbon atoms and an O2 molecule joined together. And what did I end up with in the products? Carbon monoxide. 2 carbon monoxide molecules. If you didn't know that was carbon monoxide, that's okay. Carbon monoxide is just 1 carbon bonded to 1 oxygen. So we would say that this reaction is balanced. Okay? What about this reaction? Is it balanced? 4 carbons in the reactants, how many in the products? 4. How many oxygens in the reactants? 4. And in the products? 4. Is this a chemical reaction? Yes. New, chemically different substances are formed. Did we create carbon or oxygen atoms? No. We just changed how the carbon and oxygen atoms were bonded to each other in themselves. Okay? So let's look at this sample reaction. So let's talk about the sample reaction together, and then I'm going to give you guys time to write down. I'll give you time where I'm not talking. But let's look at this reaction. We saw this reaction Wednesday when we talked about types of chemical reactions or signs. So this is the reaction for the combustion of propane. So if we look at this, how many carbon atoms are there in my reactants right now? 3. How many carbons in my products? 3. It's got a, what is this big number out in front called? Coefficient of 3, and then a subscript assumed to be what? 1. So 3 carbons. How many hydrogens in my reactants? 8. This is the 1 here times 8 is 8. Don't know why that was hard. And then the products, how do I handle the 4 and the 2 for hydrogen? Multiply. Coefficient times subscript, so what's 4 times 2? 8. So are the hydrogens balanced? Yes. And then the oxygens, how many in my reactants? 5 times 2 is 10. And in my products, very good place to look. So we're looking at all of the oxygens in our products, right? So I have oxygen here and oxygen here. Just add them all together. So how many oxygens here? 6, plus how many here? 4, for a total of 10. Very good. So what you're going to be able to do by the end of this lesson is figure out the coefficients, so the 1 here, the 5 here, the 3 here, and the 4 here, that balance a chemical reaction. So that's our goal by the end of today, is to figure, today and Monday, to figure out balancing reactions. So, we talked about why, law of conservation of mass. Now let's talk about how. So I'm going to let you write this and then we'll talk about it. I promise that. So, going to look at different reactions and practice that. Practice changing the coefficients so that we have the same number of each element in the reactants and products. So here's a few tips and tricks. I'm going to let you write these down. We'll talk about them as we go through different reactions. Okay, so when you are balancing, take inventory. Figure out what atoms you have in your reaction and how many of each atom you have in your reactants or products. Then, if you have an atom, and we'll see examples of this, where it's alone, save it for last, because that's the easiest to balance. If it's alone, it means adding a coefficient to that atom isn't going to change anything else. Like if it's in a compound, if you add a coefficient, it changes everything in the compound. Polyatomic ions. I'll point them out when we get to them. We can treat them as a single unit. It will make it easier. When a reaction is balanced, you need to double check that the ratios are the lowest whole number ratios possible. So if you got coefficients that balanced that were 2, 2, and 4, is that the lowest possible ratio? No. What could you reduce that to? 1, 1, 2. So just after you're done balancing, take a quick look and make sure it's the lowest whole number ratio. Now, if you accidentally leave one that's not in the lowest whole number ratio, it would be very little points taken off, and your ratio is still true, right? The ratio of 2 to 4 is the same as the ratio of 1 to 2. So in terms of it affecting your math as we use balanced reactions, it won't affect it negatively. It's still the same ratio. And then combustion reactions save oxygen for last. And we'll talk about why. It goes back to kind of that second trick where save things for last that are alone. And also, because we have oxygen in the reactants all by itself, it's the easiest. And it's in both of our products. So let's look at some examples. So we're going to go through these. I'm going to give you, there's a bunch of model examples. Some of these I'll do with you. Some of them I'll give you a second to do and we'll check them together. But if you guys will just go ahead and write this reaction down, then we will talk about it. Okay, so let's look at this one. So how many magnesiums right now, the way it's written, do I have in my reactants? 1. And how many magnesiums in my products right now, the way it's written? 1. In my reactants, how many oxygens do I have right now? 2, right? And how many in my products? 1. So when we say take inventory, if you're very visual, this is one way you can do it. You can just make a list of the elements, put how many in the reactants and products, and keep track of it that way. So if you get to a point where you're like, I'm struggling to balance this, try the inventory method. And maybe slowing yourself down there, you'll be able to make some connections. A lot of you won't have to use this inventory method, at least not for very long. So what's not balanced right now? Oxygens. I have 2 oxygens in my reactants and 1 in my products. So the only thing I can do is add coefficients. Subscripts come from how they balance. We can't change that. So where would I add a coefficient? Go ahead. Well, would that fix the oxygen right now? Right now, the thing that's not balanced is my oxygen. So what if I put a 2 here? Can I put a 2 there? Yes, that's a coefficient I can add. What does that change? It gives me 2 magnesiums in my products, and also what? 2 oxygens. My only choice was to put a 2 there to balance the oxygens. But now that I put the 2 there, what has it done to my magnesiums? They're not balanced. So what do I need to do to balance the magnesiums? Put a 2 in front of magnesium in the reactants. Very good. So now how many magnesiums do I have in my reactants? 2. Is everything balanced? Once everything's balanced, any blanks you have, you can go ahead and put in a what? 1. Now, you do not have to write in the 1. Let me give you a cautionary tale about why you might want to. 1, it's a way to indicate to yourself that you've finished balancing the problem. So if you've waited until the end to put in 1s, then when you go back and look at a problem, you know you're done with it. But if you stop on a problem and have blanks, then you can indicate to yourself, I need to go back and look at that. I was struggling with it, okay? So that's just a way to keep yourself organized. The second one, which could potentially be more problematic, is it's fairly common to see a question that asks you for the sum of the coefficients that balance a reaction, okay? So what's the sum of the coefficients that balance this reaction? 5. Believe me when I say I have had some of my very top students who knew balancing backwards and forwards, that on a test that was over in IB chemistry, the only question they missed was the sum of the coefficients because they forgot to add in the 1s. And it wasn't because they didn't know how to balance it. They just did the problem too quickly and forgot to add in the 1s. And so if you get in the habit of writing in the 1s, it just will also help you with summing the coefficients faster too, and correctly. I wouldn't count it wrong if you didn't have a 1 there, because it is an assumed 1, but it could help you. Okay? I'm gonna let you guys write the next one. And if you feel comfortable, you can give it a try. We are going to work it together. Okay, so let's look at this one. Let's take inventory. So we've got sodium and chlorine. How many sodiums right now do I have in my reactants? 1. And in my products? 1. How many chlorines right now in my reactants? 2. And in my products? 1. So what's not balanced right now? The chlorines? So I need more chlorines in my products, right? The only thing I can do is add coefficients. So what's the lowest coefficient that would give me 2 chlorines in my products? A 2 in front of NaCl. So that changes my chlorines in the products to 2, but what did it also change? The sodium in my products to 2. So then how am I going to balance the sodiums now? Put a 2 in front of sodium in the reactants. Now are the sodiums and chlorines balanced? So what coefficient can I write in front of the Cl2 in my reactants? 1. What type of reactions are these two? Composition. Why? You make one product. Very good. Okay? You guys go ahead and write this one. I have aluminum. What else? Iron and oxygen. So right now, how many aluminums do I have in my reactants? And in my products? 2. How many irons in my reactants? 2. And in my products? How many oxygens in my reactants? And in my products? Okay. So the good news is the oxygens right now are balanced, right? So do I need right now to add a coefficient to the Fe2O3 or the Al2O3? No, because the oxygens are balanced, but the aluminums and irons aren't balanced. So what am I going to do? I have 2 aluminums in my products right now and 1 in my reactants. So what can I do to balance that? I can put a 2 in front of aluminum in my reactants. And my irons aren't balanced right now. I've got 2 irons in my reactants and 1 in my products. So what can I do? Put a 2 in front of iron in my products. And now is everything balanced? So then what can I put right here? 1. What type of reaction is this? Single replacement. We have an element reacting with a compound. And what element does the replacing in this? Aluminum, right? Aluminum replaces iron. It's a single replacement. One thing replaces another. In a double replacement, you have 2 things replacing. How are we feeling about balancing? Good? Okay. You guys go ahead and write the next one, and if you want to, I mean, obviously, you can always work ahead of where I am. But if you feel comfortable, you can try it. Okay, let's take inventory. Right now, the way the reaction's written, how many phosphoruses do I have in my reactants? 4. And in my products? 4. And then oxygens, how many do I have in my reactants? 2. And in my products? 10. So right now, phosphoruses are balanced, but the oxygens aren't. So what can I do? I need to put a 5 in front of oxygen in my reactants because 5 times 2 gives me what? 10. So now is it balanced? Yep. So I get a 1 in front of the P4 and the 1 in front of the P4O10 in the products. What kind of reaction is this? Composition. Good. Very good. So what did you have to recognize on 5? Can I just multiply Br2 by a whole number to get 3 bromines in the reactants? No. So I'm going to have to multiply bromine in the reactants by a whole number, and then the PBr3 and the products by a different whole number. And what's the smallest whole number that I can make 2 and 3? Both of those two numbers I can make the same whole number. There's a name for it, greatest, or I don't know, least common multiple, whatever. What is it?
6.
It's 6. Whatever it is, it's 6. So what do you multiply by 2 to get 6? 3. So I'm going to make this coefficient 3. And then I'm going to put a 2 in front of PBr3. Do we agree?
Oh, yeah. You get to make that 2 or 4.
Okay, so
Okay. You gotta up those by 2. I was confused.
that's not going to work, right? Because of the 4 phosphoruses. So if those don't work, try multiplying them by 2. So make the 2 a what? 4, and the 3 a 6. And then are the phosphoruses balanced? Hi. Okay, okay. What goes in front of the phosphorus? 1. Good. What type of reaction is 6? Double replacement. We have a compound, potassium iodide, and another compound, lead 2 nitrate, and they both switch partners, so it's double replacement. So in this compound, we have potassium. How many potassiums in my reactants? Right now, there's 1. And in my products? 1. I also have iodine. How many iodines in my reactants? 1. And in my products? 2. Do you see why 2? And then how many leads in my reactants? 1. How many leads in my products? 1. Now remember when I said the polyatomic ions we can treat as a single unit? Okay, this NO3 is a polyatomic ion. And so the reason why we can treat it as a single unit is because I have NO3 in my reactants, and I also have NO3 in my products. So we can just treat it like it's one smiley face and balance it as a single unit. You can balance it separately. You can balance the nitrogens and the oxygens, and they will balance. But it's just a trick to treat it as a single unit. So notice in my inventory, I wrote NO3 all together. So how many NO3s do I have in my reactants? I have 2.
Oh, and okay, got it.
Do you see that? How many NO3s do I have in my products? 1, right? So where do we want to start?
The potassium iodide.
Okay. Okay. So what do you want to put in front of the Ki, potassium iodide?
2.
Okay, let's try 2. So that makes potassium 2 in the reactants and iodine 2 in the reactants.
And then the iron, no, the lead iodine thing, you put 1.
I wait until the end to put ones. Everything's not balanced yet. What's not balanced? The potassium and the nitrate, the NO3. There's 2 of each of those in the reactants and 1 in the products. Put a 2 right here in front of the KNO3. So how many potassiums does that make in the products?
2.
2. And how many nitrates, how many NO3s in the products now? 2. Now are all the atoms balanced? Yes. So in the blanks, what do we have? 1 and 1. Not so bad?
Not so bad. It's just kind of cold in here.
Okay, the reaction 7, what type of reaction is it? It's single displacement or single replacement because zinc replaces hydrogen. There's one thing replaced.
Thinking of the examples my teacher was giving in order to memorize it. It was like
Look at reaction 7. There is another polyatomic ion. Do you see how we have SO4 in the reactants and SO4 in the products? So you can balance out as a single unit. You don't have to. When I was your age, I didn't like treating it as a single unit, so I balanced it just as sulfur separate from oxygen. You can do that. It still has to balance. You just can balance it as a single unit. So I'm going to give you a second to balance this one, and then we'll see if we agree. What did we decide?
All twos.
Okay. So if we set all twos, I'm going to write in all twos because it helps us. It'll help us with one of our rules. All twos is balanced,
But you can simplify it.
but I can reduce, right, all of the twos into what? Ones. So this reaction is balanced the way it's written. And that is not uncommon to find, that reactions are already balanced. You guys try 8, and then we'll check it together. How'd you guys balance this one?
1, 2, 1, 1.
So right now, the hydrogens and chlorines aren't balanced, right? There's 1 hydrogen in the reactants and 2 in the products. So we can try a 2 in front of HCl in the reactants. That's okay. And does that balance it? Yep. So then the other ones are 1. What type of reaction is 8?
Single replacement.
Single replacement. So you guys look at 9. It is balanced down below for you. What type of reaction is it? Double replacement. No, single replacement. Sorry. Single replacement. It is balanced. So, well, it needs coefficients of 1, 2, 1, 2. So right now, what's not balanced? A lot of things, right? So what I notice when I look at this, I notice that the hydrogens and iodines aren't balanced. So what I might try is a 2 here. That would balance the hydrogens, but not the what? Iodines. And if I did it the other way and tried to balance the iodines and put a 3 here, it's not, then the hydrogens are not balanced. So what's the lowest number I can make hydrogen and iodine? 6. So if I try a 6 here,
So it's 2, 6.
hang on. So now there's 6 hydrogens. What can I put here? 3. And then what do I need to put in front of the MnI3 in the products? 2. Is that the lowest whole number ratio? Yes. Good. What about on, and what kind of reaction is that? Single replacement. What about on, did we already do 11? Hang on. Yes. Okay, deleting that. We already did it. It might help you to visualize writing water instead of as H2O. This is just visually. We can write it as this. HOH. That might help you as you're practicing balancing. That might help you, one, see that this is what kind of reaction. Double replacement, right? The hydrogen from HBr and the hydroxide from MgOH combine to make water. It may also help you visually with balancing. For some reason, this is the type, this question 11 is the one that kids will get tripped up on just because you've got hydrogen in 2 places in your product or in your reactants. So I would start by balancing the bromines. Because if you do that, you need to put a 2 in front of HBr in your reactants. And then if you count up all of the hydrogens in your reactants, you've got 2 here, right? And 2 here to make what? 4. So put a 2, and then do the oxygens balance? Yes. Do you see this, the parentheses here? That 2 goes to the oxygen and the hydrogen. And then these become ones. So when you're balancing combustion reactions, like example 12, save oxygen for last. Because when you balance the carbons, you'll change the oxygens in carbon dioxide. And when you balance the hydrogens, you'll change the oxygens in water. So if you balance carbon and hydrogen first, then you can balance the oxygens. So how many carbons do I have in my reactants? 3. So I'm going to try a 3 here. Do we agree? Okay. How many hydrogens do I have in my reactants? 8. So what coefficient would I need in front of water in the products? 4. Okay, now you have 4 oxygens with water and 6 oxygens with carbon dioxide to make a total of 10 oxygens in your products, right? So how will you balance that with the reactants where you have 2 oxygens right now? Put a 5 in front of O2. So now everything's balanced. So what coefficient goes in front of the C3H8? 1. And what kind of reaction is this?
Double.
Combustion.